Hello everyone, and we are team BioBridge and from the JCRC Foundation, and today we are excited to present the case study on how to make enhanced medical diagnostic equipment using modern cloud technologies and mobile integration. In this project, we have explored both hardware and software upgrades that can transform traditional machines into smart connected devices, paving the way for smarter, faster, and more secure diagnostics. Our team includes Akash Gupta, Alokit Bharadwaj, Akshat Gupta, Arin Sharma from Artificial Intelligence and Data Science branch. Each of us has contributed across research, hardware design, software planning, and ethical analysis to make this case study complete. So, what is what is this BioBridge? Well, BioBridge we inspired from a name where we are bridging the biology, the science, the medical equipments to the new modern equipments and the modern technology basically. So, um, in simple terms, we took a typical diagnostic device like one that reads ECG, blood pressure, and redesigned it to be a cloud-based enabled technology and which can be accessible via mobile app. So our goal is to make diagnostic more real-time and portable and more accessible. So the during our research, we found the major flaws between these old age technologies that are used in medical diagnostics. So here are the top five hardware changes and software changes that we required for this our project. So to achieve that, we analyze the current gaps in medical equipment and propose a system that can capture vital signs in real time, send securely to the cloud, and let doctor and patient assess those reading instantly and anywhere. And hard. So let's look at the top five hardware changes that we are to go through. IoT sensors to collect patient vitals like ECG and BP on the go, faster processor, so that the device handle real-time data very efficiently. We are using secure wireless Wi-Fi and 5G modules for seamless wireless transmission, extended battery life for mobility, and uh, we include and for the security, which is the main important thing for a user, client, or any doctor. So we are using encryption, RSA encryptions. Now, let's look at the software requirements in which we have followed the RISE model to prioritize our features. We focused on reliable cloud syncing, a mobile app for real-time monitoring, AI-powered analytics, strong user data privacy controls, and remote firmware updates. Together, these features turn our hardware into smart, data-driven device. Now, let's look at the project management plan for the product launch. Now, we have to deliver this project, we created a structured project management plan, and the goal is to launch within 12 months while managing hardware, software, and compliance. We have identified dependencies like development and approvals and planned mitigations for delays by working with vendors early and tracking milestones consistently. We considered risk supply chains delays and tackled them through early vendor management, parallel software hardware development, and regular milestone reviews to stay on track. Now, let's look at the test plan and scenarios for the new offering. Testing is critical in healthcare. We developed 10 robust, robust test scenarios, including accuracy of vital reading, cloud sync under weak or unstable data network, mobile app user interface responsiveness, security testing for data encryption and access control, and battery performance under real use conditions, sensor collaboration, system recovery, and after network failures. Compliance with medical device regulations, user acceptance testing with real world scenarios. We want this device to perform flawlessly even in demanding medical environments. So we will be testing our new product in these scenarios to check whether it is uh, capable enough to perform in these situations or not. Hmm. Now, we will, the main twist comes here, the real magic begins. Once the data flowing, it is very important to see what, where we have, what type of data is being collected, where it is being used, how it is being accessed, and we have, so so here's what we will be collecting: patient vitals, users logs, and environmental factors, diagnostic histories, for result for the trend analysis. And with this, we can apply AI and data science, that is our branch, artificial and data science, to predict potential health issues, offer personalized health insights via mobile, and machine learning to improve data accuracy, remote monitoring, and alert system. So, uh, we, uh, so we will be collecting these data, and we will be applying these data to the use. We will be applying this data. So we and the collected data will be used to train the AI using data science application, so that the health our app adapts and learn accordingly to the new diseases and viruses. So the user. So now let's talk about the user experience, the front end that patients and doctors will actually use. So our our UI UX approach is based on simple navigation, clear visual hierarchy, accessibility for all user hierarchy, fast responsive design, and consistent branding. We have scratched a mobile app UI with real-time vitals, alert, and history, all available with just few taps, intuitive UX with few taps. So our principle is that intuitive UX is equal to better adoption. We will try to make our UI UX design so simple that it doesn't require any old person or a person who doesn't know how to use phone or anything to make it will without to make them use the app without any tension or without any problem. Now, while of course the project we made is like it's very ideal, it's very perfect in all conditions, but we all know that there is nothing such thing called or known as perfection. So while making this app or while doing the research, we have done or we have made some few assumptions, like user having stable data and team the user having stable data, team being skilled in development and testing, like there will be no issues in the data collection or the report that is made by the doctor and the cloud infrastructure will be reliable, like the cloud infrastructure will never fail. And on the ethical side, we heavily focused on patient data privacy. Like we will be we will make sure we will be using proper encryption techniques so that the patient data doesn't get leaked, and no there is no unauthorized access of the patient data. Transparent data use policies, inclusive design for elderly and differently abled users, and responsible use of AI. No black box decision, only helpful suggestions. We believe technology should serve human ethically and responsibly. So, now we here come for the key takeaways from what we, what we have done and what we have discussed so far. We have proposed a smart diagnosis system combining cutting edge hardware and cloud based software. We have laid out a 12-month plan to build, test, and deploy the product. We have addressed both technical challenges and human factors, and we have stayed focused on ethical, secure, and user friendly design. Next steps include building a working prototype, conducting real world testing, and preparing for a controlled deployment in clinical settings. It will be very difficult, as in real world the problem that we have assumed, the problem we think can increase also. But yeah, uh, we will be doing. So, uh, to conclude, the MedConnect or the BioBridge isn't about the tech. It is about making healthcare smarter, safer, and more accessible for everyone. This project has helped us engineers grow as engineers and as problem solvers. Human-centered design. Thank you for your time, and we welcome your questions and feedback.